Hi, everybody. Welcome to your next session right here in the .NET Conference. We're going to spend the next 55 minutes or so talking about mixed reality. And I was just getting done setting up, so bear with me one more second. I just need to test the network. All righty, let's get started. So the title of this session is Windows Mixed Reality at 90 frames per second. And like I said, we're just going to spend some time talking about mixed reality. My name is Jaime Rodriguez. I work for Windows, the PAX team. I work for the Windows PAX team right here in Redmond. And I've been doing mixed reality for the last 6 months with immersive headsets. So I've been helping partners bring their applications to the platform. For context, for anybody who is familiar here with the Universal Windows platform, we are going to be talking about Universal Windows apps. Anybody who understands the premise of Universal Windows apps knows that the premise is simple. You actually get to write your application once using WinRT APIs, and then you can target a myriad of devices, for example, Xbox or mobile or PC, or since 2 years ago, HoloLens, which is our holographic platform. And today we're going to talk about holographic, but we're going to talk about it in the context of the occluded headsets, so these virtual reality headsets. So we are still doing universal apps. We're using the exact same APIs that we use for holographic. In this case, we're just targeting the occluded headset or the immersive headset. Now, whenever I talk to anybody about mixed reality, the first question they ask is, why is Microsoft call it mixed reality? There's augmented reality, there's virtual reality, but there's not such thing as mixed reality. And Microsoft insists on using this term mostly because we think about the realities in different terms, and we have technology that converges all of these realities together. So we want to make sure you understand what you're looking at, and I want to make sure today you understand how to build a mixed reality application across the board. So what I'm going to do is I'm going to actually build an application that targets each reality, and you'll see exactly how we converge or how our technology plays well together and how one universal app can go across the board. So let's start with that because that's the easier way to get started and understand the concepts that we're going to cover a little bit later. So for today, I'm going to use Unity. If you're not familiar with Unity, they're a very popular game engine. They're actually one of the more popular engines for virtual reality too. So if you go out there and look at Steam or Oculus, easily half or 50% of the titles out there are on using Unity already. So it's a very popular technology and one that you can easily port across the board. So for today, I'm also going to use Unity 2017.2 Beta 11. If you're going to target the immersive headsets, you need to be on the 2017.2 branch. Right now it's Beta 11. I think within a couple of weeks, Unity will be going to RC, and then we expect the 2017.2 to actually RTM probably within 30 days or so, maybe 30 to 45 days. You can go live with using the beta for 2017. So if you wanted to submit an application to the store around October 17th, when our store opens for these kind of applications, you would be able to do that already. And again, I'm going to cover the whole gamut of the universe of mixed realities. So let's start right here with augmented reality. And for all of these applications, actually, for all of those applications that I'm going to show you right now, the code, there's actually a very detailed script and step-by-step instructions of everything you're going to see right here on GitHub. So you can go to my GitHub. There's this holo demo that I published. And it has step-by-steps or everything I'm going to show you. So I'm going to go pretty fast. And in some cases, I'll have scenes that are pre-set up. But if you need step-by-step on how to build it, how to demonstrate this, and everything else, you'll be able to find it right here. So you'll see here the commands. You'll see the demo script. And again, you'll see step-by-step on how everything gets built from scratch. In the interest of time and to not bore you so much, I'm going to skip a few of those things. And then it's just setting properties and things like that. But all of the concepts and all the important relevant stuff, you'll hear from me and you'll see me do it in action. So right here, I'm beginning with a pretty much empty scene within Unity. And we have a camera. And what I've done here is, because I'm going to start with augmented reality, I added a reference to the Vuforia SDK. So Vuforia is a very popular technology for doing augmented reality, and I added a reference for it. And we already have a reference right here. And I added 2 prefabs. Prefabs is the term we use in, or people use in Unity for components. So a prefab is just a component or a control that you use. In this case, I added 2 prefabs right here. You can see here, if I go into the Vuforia SDK and I look at the prefabs folders, they have the AR camera, and then in this case they have an image target. And the reason I use an image target is because the demo I'm going to show you is going to look for an image in a surface, and then whenever it sees the image, it's going to take an action. So it's kind of augmented reality where we detect a marker and we show something against that marker. So right here, the only thing that we have left is for our scenario, we need what to show with that marker. So what I'm going to do here is I went into Paint 3D. And I just clicked on the Remix 3D right here, which is the community. You find a lot of free models, 3D models right here. So in this case, because we're going to explore the universe, I kind of picked this alien. So I'm just going to go right here and pick these aliens. I can zoom out a little bit just so you can see it. I can scale it a little bit. We're going to export it, so me scaling it doesn't matter. And you can see here, this is Paint 3D included with Windows 10, and it's a full-blown 3D modeler, or a friendly 3D modeler. It's not, you can use Blender, you can use any other technology you have, Maya, Blender. But in this case, I wanted a very simple model, so I went right here with Paint 3D. And all I did is I went right here and I say export file, and I export it as an FBX, and I put it right here into the project that we're using, which is called Alien VR Ship, and I'm just going to call it Alien, or Demo Alien. And that's it. Once I do this, Unity right here is automatically going to import it, and then we'll be able to use it for our project. In this case, for my scene, just on the interest on time and make sure everything was fine, I have a copy of the alien right here. So for example, if I go here, you'll see our alien is already there, and I can navigate right there. If you want to see the one that I just exported, it's right here in the demo assets folder. You can see the demo alien that you saw me export just a minute ago. Now, my setup was complicated, and this studio is not very large, so I could only project from one PC. So for me to show you what the augmented reality version of it is, I pre-recorded a video because I would have needed an extra PC and output from that extra PC. So here we have, again, look at what we've done. We added an AR camera, which literally is just dragging a prefab from right here, from Vuforia. On the prefabs folder, all I had to do was added this prefab right here, is dragging it right here. I didn't have to configure many properties because the default ones work fine. And then I also added an image target, which again is the same target you see right here. So honestly, I haven't written any code, and our scene is actually ready to go. And let me show you how you can do AR with what I just showed you. So right here, you'll see right here, this is the exact same demo we just showed you. And I was using a Surface Pro, so there was nothing magic about the camera. And you see here, as I just like scan through around, it begins and there's no alien right there, and then it finds our image target, which is this UFO target that we have right here, and then it shows you the alien in there, and you'll see here in a minute that it's tracking the scenario. You might have heard jump right there if you can hear the audio. So I just gave it jump command. I can interact with the object, and you'll see here that as I move the image around, the object is actually being tracked. And that's augmented reality. It's that simple to do augmented reality. And it's part of our mixed reality universe, but it's not all of it. Because if you look at here, that's a great demo, but it's a very simple demo, right? It doesn't understand that there's a table. It kind of has to have a marker in there. There's a lot of things that it didn't do that I think we can do, or we can do a little bit better. And what we've done for that is, 2 years ago when we introduced HoloLens, HoloLens has a lot more technology, much more than that camera on that Surface Pro. And HoloLens can actually understand the environment. So let's go back to our demo and switch scenes a little bit. So that's our augmented reality demo. All I did was drag the camera, drag the target. Let's go and see what we would do if we were going to do HoloLens. So I can go back here, and I'll just go into my scenes and look at the HoloLens scenes, and I don't have to save this, so I'm not going to use it anymore. So here I have the exact same thing. I have my alien, and I just added the alien right there in front of me, 2 meters in front of me, and in the Z-index. And it's going to be at my height, so I should be able to see it straight up. And then what I did here is, first of all, there's no AR camera like we did with Vuforia. Here, we're just going to use the standard camera that would come with HoloLens. And all I've done here is went back and I added a solid color. I made my skybox black, and the reason for it is because the HoloLens is a see-through display. So with the HoloLens, anything that is black is actually rendered transparent. So if I make the background black, then you'll be able to see the whole scene of everything that I would have. And here I have my alien, the exact same one. And then I added this component called Scene Manager, and this is just an empty game object. I can just come back here and say game object create empty. And then I added two behaviors that come with Unity already. I added the spatial mapping renderer. So literally all I did was click on it and add it. And in this case, I also added spatial mapping collider, which could have been optional, but I went ahead and added it. So that's what I've done. That's what my Scene Manager object right here is doing. And that's where you're going to see in action in 1 second. And the reason I added this is because I want to understand the environment. So HoloLens can do much more than the AR kit. AR was great because it brought this digital object into, it augmented my real world with that digital object. But here, I'm going to do a little bit more. I want to interact, or I want to have my digital object interact with the world. So again, this doesn't fit in this demo, so I'm in this scenario right here. So I'm just going to show you a demo of what it does right here. So you see right here, this is a demo from Builder in Sydney. I was looking at the HoloLens, exact same thing. You see exactly what I was seeing through the HoloLens right here. You can see that I can hit test it. It's in a real world environment. You see this exact same laptop right there sitting on stage. And then what you see here in a minute,
spatial mapping.
The command was spatial mapping. And when I did that, HoloLens automatically starts scanning the environment and understanding it. So it's actually building meshes around the things that it sees around you. In this case, the walls, the floor, and everything else. So once I started, mapping the environment, you'll hear a command there where I show and hide the mesh, because I can do that. It's trivial to do that. And then in a minute, I'm going to give that alien some gravity, and you'll see what happens when he falls down. You'll see he fell down right there, and he actually stopped at the floor. So he literally collided with the floor. And this is mixed reality, right? This is the concept of a digital object, which is our alien, interacting with a physical object, which is our floor. It's that convergence of these two realities that we call mixed reality, and that's what Microsoft's vision is for everything we do. So in this case right here, I'll replay the video because I was talking a little bit. And what you see right here is I can give it the exact same commands. And it's actually collided there with the floor, and it's actually interacting with the floor as it falls down. And then just so you see that it's real, what's going to happen here, after it falls down on the floor and jumps a little bit, I'm going to give it the command to stop mapping the environment. So I'm telling HoloLens, hey, ignore everything that you see, ignore all the special meshes that you identified, which is the ones that I collided with. And you'll see right here, when I give it that command, it actually the alien goes away because it falls through the floor because there's nothing anymore holding him down. So he's jumping right now. And then in 1 second, I'll just give it that command. You might be able to hear it. I can't hear it here because I was there, and he fell through. So that is the convergence of physical reality, our floor, and virtual reality, our alien, which is a digital object. So that's mixed reality, and that's where we're going. That's where Microsoft is going. Now today, I want to talk about a component that we have in that mixed reality universe, which is again this immersive headset or virtual reality. And this is where we're going to start diving down through a few things. I'm going to show you a couple more, or get a little bit more into the exporting and creating the project. So here's kind of where we begin looking a little bit at more code. So that was HoloLens, and that was the mixed reality. I can come back here and now show you the immersive reality. I don't have to save this scene. So I have right here, I'm going to have an included HoloLens. So I want to create virtual reality. And I have my scene right here, and I have my alien. And he's already in a universe, so kind of gave him a little bit of background because I'm going to be occluded. So I want to give it that sense that something is, that I'm in the universe. And I put the exact same alien I had. Again, it's the same FBX, nothing interesting, nothing too fancy or hard about what we've done. And what I have right here is I have my mixed reality headset. And let me just make sure. I'm going to go to the mixed reality portal and just make sure this is on. And it is right now. So I have a mixed reality headset. And this mixed reality headset is connected to my PC only through HDMI and USB. So this is an easy setup. If you're familiar with Rift or Vive, you usually have to put lighthouses in your room, hanging from, from the ceiling or something like that. With Microsoft's mixed reality, because we're using some technology called inside-out tracking, we don't need any of those things. We're just going to have the headset, and we'll be able to track this as we go. And the first thing I'm going to do is I'm going to show you this scene within the Unity editor, so you understand kind of how you develop for mixed reality. So in this case, I'm just going to click right here in the Unity editor. Play, and what's going to happen here is this mixed reality portal, which comes with Windows, and it's something that is there all by default, for both users and developers. It's not so much a developer tool. It's actually going to mirror everything that I get to see here with the headset. So what I'm going to do is I'll put the headset on, and I'll flip it like this, and then I'll go into Unity and I'll just say debug. I'm going to Unity right here. And I'll tell it to debug, and I'll make sure I bring focus to the mixed reality headset so you can see it. And now, within Unity, you should be seeing exactly what I'm seeing here. And you see my universe right here, and you'll see the universe as we have it. And now we're in virtual reality in a universe, but that's kind of boring. So let's go back here, and realities, I forgot to click on this one button. So I'll just go here and enable an object, and then I'll do the exact same thing that we did. And now, within Unity, you see the exact same thing. I'm running virtual reality, but now I'm actually in a cockpit, and I can walk through it. For example, right here, if I don't file, I can walk through the cockpit right here. You see the floor. So my immersive reality headset identified the floor, and you see the back of my cockpit, and I could sit down, and later on, if we add controllers, we'll be able to drive it a little bit around. So this is virtual reality. When you're in the Unity editor, it doesn't look as impressive, but if you're looking at this and you're completely occluded, it's a very like immersive experience. Like you actually feel that you're in the cockpit and you're actually with outside in space in the cockpit. So that's how we develop, within Unity. You saw nothing special. It's just standard FPS. It's just a standard Unity scene. How do we target a universal app? How do we create a universal app? It's very simple. I can come back here, and from within Unity, I just said, in my build settings, I set it to be a universal app. And then in my player settings, I can come back here and configure it to be, in this case, mixed reality application. So in extra settings, I can just say, virtual reality SDK supported, and I clicked it. And in this case is Windows Mixed Reality, and I left all the other defaults by file. Actually, the one thing that I changed here also is I changed it to be C#, because Unity has C# and IL2CPP. In this case, I saved it to be C#, and I can just come back here and build a project, and then give it an output. It's .NET Conf CS, and Unity is going to compile everything and build a Visual Studio project that we can then, from within Visual Studio, debug, deploy, and do everything as we would any standard C# or any standard .NET application. And this is standard workflow for any UWP application. It's not specific to mixed reality. It's how we do all the applications. Now this takes a few minutes, so we'll let that one go. And then I can walk you through the project in a minute so you can see the structure. Here's a pre-baked version of that. You'll see in a minute it's going to refresh everything. You'll see everything we have right here. It's got assembly C#, which were my scripts where I had the things that we were adding into the project. And then it has my game right here. In this case, this is a different game because it's a different pre-baked version of something else. We're going to use it in a little bit, but it gives you the exact same structure. So we'll see when this completely exports, you'll see the exact same structure, and we'll just open it. So that is the gamut of mixed reality, and that's why Microsoft keeps using the term. Our long-term direction is obviously that's convergence of physical and virtual. What you saw with HoloLens, we want to bring that to everywhere. And so for me to tell you how we're bringing that to everywhere, let me walk you through a little bit of what we're doing and what kind of technology is going into this headset. So I'm going to go back here into PowerPoint, and let's walk through what's in a HoloLens and what we're adding onto our mixed reality offer. You see right here, the project is now done. We'll go ahead and launch it. And you will just see standard UWP, C#, everything that you would expect from a .NET project is there. NuGet packages, references to the UWP libraries, reference to Euphoria because we were obviously using that. Everything is there as you would expect. And these I can press F5 and debug, and it's going to do the exact same thing that you saw happen in Unity, where the mixed reality portal will deploy and you'll debug from there. So very, very straightforward. So let's go back here. And again, I was going to show you what we're doing with these mixed reality headsets. So this is HoloLens, and again, this is our vision. This is where we are going with mixed reality. This is where we want all these technologies that we're going to show you to evolve towards a similar model or an iteration of this. So the first thing you should know, HoloLens is an untethered computer. So it's a full-blown computer. This headset right here is not a computer. It's actually tied or plugged into this beast, this portable heater that I carry with me. HoloLens is its own computer, so that's one of the differences that you'll see. No big deal. That's just where we're at. It's got different capabilities. Here's where the secret sauce comes in. HoloLens has all these advanced sensors. You see right here these 4 cameras, and this is what's actually scanning the environment. In this case, the immersive headsets had 2 cameras, so it can actually scan, it can find the floor, but it doesn't do spatial mapping because it doesn't have all the sensors that HoloLens did. The last one that you'll see, or the next one you'll see, is HoloLens also has this extra camera, which is that see-through camera. When you wear the HoloLens, it's a see-through display, so that camera is actually feeding you what you're seeing there, and it's actually recording. That's how you can get for example, augmented reality or object recognition with HoloLens, is because we can still identify what that camera is seeing. In the case of the immersive headset, there's no extra camera. It's an included headset, so we just don't have that capability. But everything else, like the sensors and the inside-out tracking technology is there. The inside-out tracking technology is what's most important because it's what helps us, keeps us mobile and knowing our position and our rotation as we go back and forth. HoloLens has a lens. This is occluded. That's just HoloLens projects into that lens. In the case of the HMD, you just have an OLED or an LCD display that you're actually displaying against. So that one's a little bit different. And then HoloLens has this holographic process in Unity. This is where the secret sauce happens. This is where all that magic around the sensors happen, and this is our inside-out technology. And again, you get the same functionality from with the immersive headset. You get inside-out tracking. And then both of them have spatial sound. So in the case of HoloLens, it actually has the audio or the speakers. The headsets, most of them have an audio jack that you can just plug into, and then you'll be able to do spatial sound. Spatial sound is something that comes, it tells you where the sound's coming from, and you can, as your head rotates, as you move closer to an object, sound gets louder, or you can actually get a sense from direction from the sound. So that's where HoloLens is coming from, and HoloLens has been very well received in the industry, but right now HoloLens is focused on commercial scenarios, right? It's still an expensive device. It's, it's like $3,000 for anybody to buy one of those devices because, again, it's a whole computer and it's a very complicated piece of equipment yet. With mixed reality or with the immersive headset, what we're trying to do is we're trying to democratize it. We're trying to bring that to everybody right now. So in this case, what Microsoft has done is we've partnered with a lot of OEMs, Acer, HP, Lenovo, Dell, Asus, and more to come. And we said, hey, we can give you our inside-out tracking technology, or we can license you our inside-out tracking technology. We can give you our platform, and then you can create virtual reality headsets, and all of them will work fine with our technology. So you'll see everything that we're looking at. So you'll be able to play in this mixed reality world, and you as a user benefit from this because you have a myriad of choices, right? If you're one of those people that likes a very specific brand of computers, you have that. If you want to go get a fashionable accessory, maybe you want the blue one or the white one, etc. You have a choice of color. You also have the choice of prices. All of these headsets are, they start at low price of $299 and then go $399. They're relatively inexpensive compared to like what's out there on the market. They're less expensive than, for example, an HTC Vive. The other thing that we've done to make sure that technology is coming to everybody is that we actually make our technology work with computers that are a year and a half, 2 years old. If you're looking, for example, when you do virtual reality and you try to do it with HTC Vive or Oculus, they will tell you, hey, great, you can do virtual reality, but you need to have this headset. You need to have our headset, first of all. And then they tell you, you also need to have a very specific PC or a very specific PC configuration, which usually amounts to a desktop or a brand new laptop, and the very big with a very powerful graphics card like this one. And they said, okay, this is what you're going to need, and that usually amounts to like a $1,200 PC or more. In our world, we do have that. If you're a gamer and you want to have the best, PC, the fastest PC out there, we call that a Windows Mixed Reality Ultra PC. And these requirements right here are very similar to the ones you're going to see from, again, Vive or Oculus. Now, what we've done is we also make sure that our technology works with PCs that are a little bit older, a year and a half old. They do have to have some requirements. So, for example, they still have to have an HDMI port out. They need to have Bluetooth if you're going to use our motion controllers. They need to have a USB 3.0 port out so we can plug the headset. But this is a much more reasonable specification for hardware. So if you're out there and you have a computer that you bought probably in the last year and a half, if you have a desktop that you bought in that time frame, this should it should meet most of the requirements right here for what we call a Windows Mixed Reality PC, which is not an Ultra PC. So mixed reality will still work fine here. And what we've done is the platform sort of self-throttles itself. So if you see at the very bottom of the spreadsheet right here, well, we said, hey, when you're in an Ultra PC, you should expect 90 frames per second. When you're not in an Ultra PC, you can expect 60 frames per second, which for a lot of scenarios is fine. If, for example, you're watching 3D or 360 video, it's totally fine to be doing it on a mixed reality PC and not have that super high-end hardware. You don't need it. So what we're doing here is we're trying to make sure that mixed reality comes to the masses when we're making sure that anybody who has a good PC and Windows 10 can actually access it. And that's where we're at right now. It's Windows Mixed Reality for everyone. We're democratizing mixed reality. And what we're bringing you is that 6 degrees, there's 6 stuff, 6 degrees of freedom that you can get from the headset through our inside-out tracking technology. We have an effortless setup, meaning you can actually just plug your HDMI, plug your USB cable, and that's it. There was nothing hanging from the wall, so that's much easier for people to do. And then we give you broad consumer choice. You can keep your PC if you already have one. You can purchase one. You can go back and find out what headset you want. In this case, I'm using the Acer Developer Kit. But you can go buy one from Dell or Lenovo or anybody else and have you have a lot of choice if you want to use mixed reality. So that's kind of what we're doing this year. And again, this is all launching in 10.17 as we launch the Windows 10 Fall Creators Update. It'll be there available for anybody who has Windows 10 Fall Creators Update. It comes with the OS. You don't have to pay anything extra for the software part of it. Obviously, you have to go buy your hardware and configure it. And we're going to talk about the controllers that go with it in a little bit. So that's our vision. That's what we're working on. Now, I gave you the demo and you saw me build it, but I didn't explain a lot of the concepts. So I'm going to step back a little bit and walk you through some of the concepts so you understand how we're building it. It's very easy to build, so it's going to be just as easy as what you saw earlier, but at least you'll understand the concepts and you'll know where to look as you're bringing your experiences to our world. So the first concept that you should look at is what we call the concept of world coordinates. And we call them world coordinates because HoloLens, it has a coordinate system that can go very, very far. Like if you're looking at Vive or Oculus, usually you're tethered to a cable like this one, and you can go 4 to 6 meters away from it. With HoloLens, we have this thing called world scale because we can anchor things and then literally walk away 20, 40 meters away from it. And because we keep track of where we were at and where that anchor was, and we keep coordinate systems relative to that, we can have much more world or much larger area that we cover for our world scale. Now, in this case, for the headset right here, obviously we are tethered. We do have the cable. So let's talk about the scenarios that this headset can address. We have 2 modes, what I would call 2 modes. The first one is stationary. And stationary is when I put my headset and I'm either expecting to be sitting down, maybe I'm going to watch some video, and I'm just expected to be sitting down. I'm not going to be too mobile. And the second one is room scale. And that's when I'm going to be a little bit mobile. Maybe I'm going to play a game or something like that. And I want to make sure that there's enough room. Here, I don't have enough room, so I would be on kind of a stationary position. And then I can come up with my scenarios. For example, if I'm going to watch a 360 video, that would be, orientation only. I can just set my stationary space type to, or my tracking space type to stationary, and then I can just say disable positional tracking. That means don't even track if my head moves up and down or anything like that. That way you don't move the camera, and all you're doing is moving the camera as I rotate back and forth, right? The next scenario that I would have is seated scale, which is the exact same thing I just showed you. The only thing here is I do want to track my head. So for example, imagine that I'm in a social VR chat application and I want people to see what I'm doing as I move a little bit, even though I'm not too mobile. I'm not walking around or jumping, but I'm a little bit mobile. So I want them to see that. And what I do there is set a stationary tracking type, and then I just recenter so that I am the center of the camera, and then everything is fine. And then if I want to play games, then I go into the standing and room scale, and there all I got to do is set my space type to room scale, and then I can actually get the bounds. So earlier when I pre-configured this for a room, I can actually configure some bounds, and then I can, as a developer, I have access to those bounds, so I know where to put, maybe treasures within my game, or where to put safety things within my game. That's the concept of world coordinates. It's very straightforward, and you just pretty much have to decide which one you're going to use. Now, the next thing that you're looking at is whenever you're doing HoloLens or immersive, you want to have gaze. You want the concept of you looking at something and knowing exactly what you're looking at, right? So for example, when we had our HoloLens, you could see the little cursor around it so that we could see what we hit testing and what we're looking at. And gaze is very, very simple. You have to write absolutely no code. All you have to do is whenever you put the camera, or you have the Unity camera, and you just leave it alone, and then automatically the platform is moving the camera around and tracking your position and your rotations. If you want to have a gaze and you want to see, show some like what's hidden or what you're looking at, then you can do a physics raycast and kind of hit test. So you shoot a ray onto the screen, and then you shoot a ray onto somewhere, and then you get a responses back on whatever you hit in the direction of that ray. And if you hit something, then you're like, oh, there's an object there, and that's all we have to do. So gaze and cursors is super straightforward. You don't have to write any code for gaze. And then there's some things. Cursors is the best practice, so I do recommend you have one. And there's best practices there, like making sure the cursor is always there, making sure you have a directionless one, so that unless you're actually having the user or forcing the user to force in a specific direction, you want to kind of like give them a directionless one. That way they don't get confused. You want to use the cursor to give you feedback, so the user always knows where it's at. And then if you have a specific input state, like, maybe you have commands or certain things, you can reflect that within the cursor. So there's a lot of that there. Another way you can interact with mixed reality, as you saw me with the HoloLens demos, was through voice. So for everything, you can actually just give it voice commands. And what we do is the platform, if you're familiar with UWP, we have speech recognizers, so you can use those. Or in the case of Unity, Unity just wraps the UWP APIs and gives you the keyword recognizer API, which is a little bit simpler object model, where you can just, for example, say, hey, I want to create a keyword recognizer, and here's the commands I want to do, like activate, turn off, etc. And then you just say, on phrase recognize, call me back. And then here on phrase recognize, you would do the work. So you can just say, hey, is the args.text was activate, then go ahead and call the activate function. Or if the parameter was turn off, then go ahead and do the work to turn off. And then all you have to do is say keyword recognizer.start, which starts listening, and that's it. That's all you have to do to add voice recognition or voice commands onto a mixed reality application. So it's very, very straightforward. Spatial sound is also very, very straightforward. What you do with spatial sound is Microsoft ships this technology called an MSH RTF driver, or kind of the functionality for HRTF functionality. It ships within Unity. You get a DLL, so it's more than a driver, and it actually just literally does the spatial sound for you. So within Unity, all you have to do is go in there, and within your audio manager, when you go into your build properties, you just say, hey, I want to use Microsoft HRTF. HRTF, by the way, stands for head-related transfer function, and it's pretty much something that is going to track what your head is looking at and then play the sound accordingly. So if I'm looking this way and the sound was supposed to come, you will actually play the sound as if it's coming from here. And there's a lot of Microsoft research and science and math that goes into doing that. You don't have to understand it, you just need to be able to use it, and you'll be fine. The only caveat with the configuration here is just make sure when you configure your spatial sound to use 48 kbps. That is the sample rate that we support. And outside of that, everything will be straightforward. Whenever you have an audio source in Unity, so wherever you're adding something that plays audio, all you have to do is click the spatialize button right here, and then it will spatialize automatically. You don't have to do anything else. You don't have to do anything special to be able to get spatial sound out of our mixed reality platform. The last one and the new one, this is the one that I'm going to dive into today because it's the new one, is the motion controllers. HoloLens did not have motion controllers. HoloLens uses gestures, which I didn't cover today because we're focused a little bit on the immersive headset. So I'm going to dive into the motion controllers and tell you a little bit of how you program them, and then we're going to go create a little demo to program them. So for motion controllers, it's very straightforward. We have two APIs. The first one is we have Unity APIs. So Unity has APIs that you could use that would work for everything. The reason some people might want to use this is, for example, somebody who has an HTC Vive application or an Oculus Rift application might have already coded their application and their controller support to those Unity's APIs. And if you just reuse your code, your C#, you just reuse it in our project, you'll be fine, and all of it will work. So the APIs that you get from there is the input tracking API, and you can do local position, rotation, recenter, everything that you would expect would happen. If you want to know if a button is down, like for example, if the Windows or the menu button is pressed, you can just get button down and pass it the right string for that axis, and everything will work. So we have in the documentation, we have the input tracking APIs, and you'll be able to see that everything is supported, and we're very, very compatible with other platforms. Now, Unity has also exposed an object model that reflects more what our mixed reality platform is doing. And here what we have is we have this concept of an interaction manager. And the reason for that is very much like with HoloLens, where we talk about gestures. We want to abstract all of our actions into interactions. That way, later on when we add new devices, maybe we're looking at the Xbox controller instead of the motion controller. You're dealing with interactions instead of dealing with very specific hard-coded things. To deal with interaction manager, all you do is you call get current reading, which every frame, and that gives you the state of everything within each motion controller. And then from there, you can look at the interaction source state. You can say, hey, was the menu pressed? Was the touchpad pressed? Where was the position of the touchpad? You just explore all the properties and extract all the information. And then Interaction Manager also gives you APIs so that you know whether a source was detected, updated. That means when something comes into the scene or out of the scene. So that's how easy it is to actually code an application. Let's go into Unity and code one. And what I'm going to do here is I'm going to show you the code a little bit, and then I'll show you the demo as we go. So I'm going to go back here into Unity. And I have, what I have here is the Mixed Reality Toolkit. You'll see in the slide in a minute a link to that slide or to that code base. So this is an open source toolkit that Microsoft ships where we include a whole lot of interactions, a whole lot of functionality for dealing with mixed reality, both with HoloLens and in this case with the immersive headset. So in this case, I'm just going to open one of the scenes here. It's one of their test scenes. So I'm going to go right here and their Mixed Reality Toolkit. And you'll see like they have a lot of scenes, a lot of functionality. They wrap, for example, they have input, sharing, spatial sound, functionality that's specific to HoloLens. In this case, we're going to go into input, and then I'm going to go into the scenes, and I'm going to the test scenes, and I'm going to open the motion controller one, which is the one that you're looking at here. And this is actually a relatively easy or empty scene. There's a lot of functionality here because it's debug information, but I'll show you in a minute how to create one from scratch where we just add motion controller support. And what I can do here is I have my controllers. So let's just make sure this left one is on. What you'll see here is I have this mixed reality parent, which is a prefab. Again, it's a component that we give you, that it's already pre-built. And you see there's controllers right here. And in this case, I have a left controller where I'm going to override with this rectangle. And I'm going to show it to you first in the debugger so you can see what it looks like in Unity Debugger. And then I'm going to show it to you in my scene, in like a real scene, where you can see the controller model here. So let me just put this on. And I'll just go here. And I'm showing to you how it's in Unity because I want to show you that you can debug and develop your Unity, your code for Unity controller. Right here within the controller. So in this case, oops, somehow the controller was not on. But in this case, I'm going to reboot it. And then I'll go right here into Unity. And I'll do the same. And now, is it finding it? It's not finding my controller. All right, I'll have to troubleshoot why it's not doing this in Unity. I'm running beta 11, so it is a beta, but this should have worked. But that's not a problem because I have the other demo, or I have the actual outcome from exporting this in Unity. And what I wanted to show you here is how easy it is to build it. So let's go here and let's test, make sure that this is working. And then I can show you controller code here. And yeah, so here I see both my controllers. Hopefully you can see my scene. Let me just move my mixed reality portal. You see every time I bring, by the way, every time I bring the headset up and down, focus switches so that the input reroutes. So hopefully now, yeah, you're seeing my controllers right here. And I'm interacting with both of the controllers right here. So I'm going to show you that exact same scene that we just built right here. And it's coming up. You see the logo, and here I actually see the controller fine. So you see right here, this is the rectangle that we were trying to override, and then I also have my controller. And you can see here, that scene that we were looking at, that test scene, gives you everything, all the input state at any one time. So for example, if I press the grip on the right hand, you'll see right here, I'm pressing grip, and you hear the haptics, and then you see the grasp turn on to true every time I press it. If I do, for example, my thumbstick and I move it around, you'll see right here my thumbstick's been moved around and everything is there as you're looking at. So this gives you, this test scene gives you everything that you would need, and it gives you all the controller functionality that you need. Let me show you how much code that was, just so you have an idea how hard it is to add controller support to your demo with the toolkit. So what I'm going to do back here, so I'm going to go back. And I'm just going to go here. I can create a new scene. You'll see actually from this scene, pay attention to this one. Is the mixed reality camera parent, and it has the camera, the controllers, and everything else. So if I wanted to replicate that and add functionality, motion controller functionality to my scenes, all I can do is go back here, create a brand new scene, and then say mixed reality camera parent, and literally drag that into my Unity scene, and it brings, you know, that prefab, and it brings everything that I needed. So it has a mixed reality camera, it has my gauge controls, and all of the functionality that I needed is there. So I should be able to, so I have all the functionality that I need already. That's how easy it is to use the mixed reality toolkit to add functionality onto your application. So in this case, that's what we had. Let me just show you a little bit more. I show you the cliff house a little bit, so I can go back here. And I'm going to show you a little bit more of the things that you can do with the controllers. So I'm going to press my menu right here. And let me just make sure you can see a little bit of this. So yeah, so you can see here, this is my cliff house, and I can navigate with the controller. So for example, here, I have my pointer, and I can point at things. I can launch applications. You know, you can see here, I have applications. Normally, my cliff house is full of apps. Though most of those apps have not been released yet, so today I emptied it out a little bit. But I can interact with the objects in the cliff house. So for example, right here, if I put these on, you see I have this little icon that I added here. And for example, I can run animations out of that. This is just a fun way for you to interact with objects in the cliff house. So I can pause the animation. You can see some of the things that I can do with my controller. For example, I can do teleporting, so I can just move around. As I look the other way on the house, I can actually come back here and move towards different parts of my house. All of the furniture that you see here is interactive, and I can do all of that with the controller. So for example, let's teleport to the top of this house, and you'll see here, for example, earlier I added a plane right here. And I can come back here and resize it, move him around, do anything I want with the controllers. And that is what that default controller functionality you saw gives you. So there's a lot of functionality that comes with the Mixed Reality Toolkit already. So hopefully you can see all of these. Yep, it's replicating okay. So hopefully you can see all of that through the mixed reality portal. And for those of you who also, if you don't have a mixed reality portal, this is right here. You can actually use them. If you don't have a headset, you can use the mixed reality portal and simulate all the functionality. So if you don't have a controller, you can simulate a controller and do input with the controllers. You know, if you don't have your own headset or your own controllers, you can just simulate it. You can simulate the boundaries here and do a lot of debugging and testings for all of these. So that's where we're at. Let's go ahead and wrap up quickly so we can get to some questions. So I showed you the mixed reality toolkit. Here's the link to it, by the way. If you knew it as Holo Toolkit, that's the old name. We just renamed it this summer. It's now Mixed Reality Toolkit, and it has a lot of functionality for input. It has sharing in HoloLens, spatial mapping in HoloLens. It has a lot of really great utilities, so I highly recommend that you go try it, right? And with that, I want to recap a little bit. I just wanted you to remember, Windows Mixed Reality just allows you to you know, target a multiple of devices. We have our Mixed Reality platform, which is coming with Windows, and then most of those APIs come through for the universal platform, and you'll be able to access them from there, and that's where you're going to get out of that. So, and with that, my call to action is very simple for you. We at Microsoft believe that mixed reality will transform industries, and we think you can actually help us do that. You have the expertise. If you're an architect or if you're in healthcare, you'll be able to do. You'll be able to actually use your knowledge, use your expertise, and our technology to build really cool apps and transform industries like we've seen happen with HoloLens in the last 2 years. So that's our call to action for today. Go download our resources, go to aka.ms/mr, and you know, play with our resources. We have a lot of tutorials there for HoloLens. We have tutorials coming for the immersive headset. They're going to be all live in 10/17 in a couple weeks. And then go download the toolkit and play with it, and you'll be able to do a lot with everything, or you'll be able to do everything they show you, and you'll be able to accomplish a lot we will give you. And that's it. I'm going to try to rush to questions. If you have any questions, feel free to drop me an email or contact me on Twitter or GitHub. Again, the code that I show you today, there's a step-by-step in there on GitHub, so you'll be able to build the exact same thing that we're looking at. And with that, let me tackle some of the questions. What resolution are the headsets? All of the headsets are 14 by 40, 14 by 40 by 14 by 40 on each eye. So technically it's 2880 by 14 by 40. So that's all of them are the exact same. So like if you buy the HP or the Lenovo, you'll be able to do the same. Are these holographic or desktop apps? That's a good question. So technically, these apps are running on the desktop. So what you saw me here, when I export my Visual Studio project, this is actually right here, the Alien in VR project that we exported earlier. It's actually a desktop application. It's running on the desktop, and we have APIs that detect, hey, am I running in the immersive headset, in which case we present an immersive view, or am I running in the desktop application? And in that case, what we will do is we will actually just let you do a 2D view and let you present a standard UWP app. So when you submit to the store, you can actually submit one application, and it will work great for 2D, and it will work great for 3D. So you don't have to rewrite it. You can be one application. People don't have to re-download it. How hard is it to port from HTC Vive to mixed reality? Well, it depends, of course. If you use Unity, it's very, very easy. You saw earlier the motion controller APIs are the same. Or you saw that everything we did was just Unity. Like, for example, Alien, just a standard Unity game object. There was no secret sauce around it. So if you have Unity, it's super easy to port your applications. If you don't have Unity, and for example, you have Unreal support is coming later in the year. Or actually later in the next year, not this calendar year, but it's coming very soon. So you'll be able to port those applications. If you have something else like your own custom engine, it comes down to how your application was implemented. But for the most part, all mixed reality on Vive and Oculus are running on Windows, so it should be pretty easy for you to port your applications as we're using the same Windows platform underneath there. So the next question is, can I write immersive apps with SAML? So today, when we create immersive apps, we actually need for you to do 3D. You can actually run immersive, or you can run your applications fine, your 2D applications just fine in the headset. So for example, if you want to watch a movie, you can go in there and do like launch the Netflix application and watch it in the headset. And if Netflix can optimize for your display and can give you a full screen, then you actually get a really great view, and it feels to you as if you're in the theater, but it's a 2D application. So those are just 2D. We call them 2D slates. It's a standard 2D application. You didn't have to do anything special, but it will run fine in the headset. Any UWP application can run just fine in the headset. It just comes down to with the display. When can I buy the controllers? Right now, the headsets you can pre-order, and some of the OEMs have actually shipped them. For example, Acer, I think Dell also sells them already. The controllers will be available in a few weeks, post October 17, as we launch the whole platform. Everything launches for us around October 17th. Terry Myerson already, went on stage at IFA and said, "Hey, we're going to launch our platform around October." And so from thereafter, it's just whenever the OEMs make them available. So it should be not too long after that. Can I use the controllers with any headset? Yes, we have one set of controllers, and you can use them with any headset, whether it's the Lenovo or the HP or any of the other headsets. And I can't read the next question. It's scrolling halfway through. It says, can I use other 3D sound like... yeah, I can't read it. With 3D sound, we give you our Microsoft HRTF code. So that's the spatializer that we give you. If you have your own and it runs on Windows and it can run within the UWP application model, then you should be able to use it. The only thing that you have to look at is just making sure that it runs within the UWP application model. And I think that was my last questions, and I see the next speakers here. So with that, I can wrap it up. I can go back here just 1 second and put, if you have any other questions, feel free to contact me. Again, jaime@microsoft.com, or on Twitter or at GitHub, just Jaime Rodriguez. And thank you very much for your time, and I hope you have a great day. Thanks.